Okay, great. So, I'd love to be interactive here. I can talk till the cows come home, and Andrew and Charles can too, but let's make this interactive and ask questions and relevant to what you all are interested in. So I'm going to give a very short intro. I'm the founder of OpenMCT, which has been going for a while now, an early incarnation from before 2010 that was Java-based, and now a web-based version, which has only the name in common with its predecessor. And Andrew Hendry is our technical lead, and Charles Haskelo is our lead interaction designer. So with that, like I said, I'm going to give a quick intro and overview. Andrew's going to talk the technical side, and then Charles will give you a demo of the software, which I think is probably the most fascinating interactive part. So I wanted to talk a little bit about why we decided to build a new platform, right? Because there's a lot of mission control platforms out there. I mean a lot. And we took the decision seriously as to why we were going to do something new. And I'm going to go back to the iconic mission control. This is from the shuttle. You can see, actually, if you look in the background there, that's STS-1, which was April 12th, I believe, 1981. I was not at NASA at that time, but I was getting ready to have a summer internship, a college summer internship that started a couple months after this picture was taken. So I've definitely dated myself there. And the environment was iconic, but it was the mainframe environment of the 60s, right? So it was pretty inflexible. Take a look at the displays. I mean, we got to the moon this way, right? It was remarkable technology for its day. Look at this display. I don't know if you all can see my cursor. And then I've printed out a hard copy of that. That display was spec'd on a grid, handwritten, and then we would handwrite our notes. We would handwrite the measurement identification number that we wanted to drive what we had written in on this display grid. And then we would, as a flight controller, we put that into another organization that would build the display. And it worked, but it was very inflexible. So we would build these displays, and then we would simulate a mission. And when we were simulating, of course, that's when we really started to understand what our needs were. But by then, it was too late to make change. And then these lights, everybody always wondered what those flashing lights were on the consoles. So here we see plastic overlays, physical plastic overlays, binary, right? Those lights could be a 1 or a 0. And again, you'd submit a measurement ID by hand, and then you drive lights that would give you statuses through these plastic overlays. And then the same theme with these hard-coded key sets that you've got on the right? This is what you would use to drive voice loops in mission control once upon a time. And those were replaced with something very similar, but much more flexible. And therein lies the kernel of an idea. And I just want to plant the question, and I'd be really curious to get people's thoughts on this, if not now, then at the end of the presentation. What has fundamentally changed in how we operate over the years? If you look at the original Mercury Control Center, which was at Cape Canaveral, this was pre-Houston days, right, to the Apollo Control Center, to Shuttle and ISS, it has been updated since then. I would argue that while the display technology is better, the voice loop technology is better, we're not using pneumatic tubes. You can see the little pneumatic tube container in the Apollo mission control. I think we're doing things in a very similar way. Certainly more efficient and more effective, and we've learned a lot. And it's an impressive operation, but I don't think fundamentally it's changed, right? I don't know that we're closer to, whatever that advancement would be, whether it's HAL from 2001 or your vision of advancement, and I'd love to get the group's thoughts on this. Now, you could argue that machine learning is taking a very limited way in space, but I would argue that those models take a long time to develop and are not really effective for types of frequent one-off missions that we do. But anyway, that's a discussion I'm hoping we can have at the end. So we set out to build a new platform and address the issues I've written down here. So, and I threw that in. I wanted to show the kind of inconsistencies that you have when you develop software environments separately, right? You see the same thing in industry, and you see suites of software being developed to be consistent. But the user interfaces were different, the displays were different, and you're putting users in a position of being integrators, and you're building walls across applications, and then you're planning your operations not necessarily based on the way you want to operate, but based at least in part by the constraints enforced on you by the walls that this software puts up. So we wanted to solve these problems. We wanted to create a platform that was flexible, that didn't have these information disconnects, and that presented users with a consistent way of interacting and displaying information, and did not put users in the role of being integrators. Okay, so how we did this, and I've got these pictures are actually very old, and Charles will show you the latest and greatest, but I wanted to highlight a couple of things with these pictures. One, which is all of your data in one place, and then also, you know, something we hadn't even thought of years ago because they didn't exist, mobile devices. That picture I've got in there is probably from 2015. If you look at the bottom, it's an iPhone picture showing data from a field test we did. It was just an early concept of, yes, we can actually get data onto a mobile device. And then you can also ask, how useful is that? And we'll get to that. So all your data in one place. Charles will show you all this stuff. View your data the way you want to see it. End user composition. Be able to assemble and put all these pieces together without being a JavaScript developer or any other type of developer, because a flight controller on console wants to focus on flight operations. They don't want to focus on the technology that they're using to enable flight operations. Andrew will talk about how we integrate data on the back end, and then, of course, plug-in architecture so we can be flexible not only for the users, but also for the developers. And then another key here, open source, and I'll say a couple of words about that momentarily. I love to throw these slides in from Once Upon a Time. And I'd be curious to know if anybody, if we were in the room, I'd ask people to just raise their hands or nod. But a couple of the significant inspirations that led to OpenMCT, the Xerox Star. I would urge people to Google that if you've never heard of the Xerox Star. It was seminal in the technology, in the development of the technology that we take for granted today. And then OpenDoc was a collaboration between Apple and IBM. And the idea was to create these typeless containers. And then those containers would hold various components that you could integrate together. And OpenMCT owes a lot to this work and the inspiration we took from those things. And again, Google it if you're at all interested. It's fascinating to go into that history of how we got to where we are today. So open source. Before we were open source, someone would call us and say, well, could we try your software? We'd say, sure. Let's just spend 3 months putting an agreement together with the lawyers. And then maybe if all goes well, you can try our software. And you can all guess how that worked out. So now we say, go to GitHub, download the software, give it a try. Another issue with open source is ownership, as in, you don't get the feeling that you are using someone else's software controlled by somebody else. It is a tremendous enabler for collaboration. And that is validated by the number of users that we have, which I'll speak to. So we've got use across NASA. That may sound like a no-brainer, but we didn't really have use across NASA before we were open source. Now we do. We've got a number of users from industry, a number from universities. And I'll just leave you with, if you're using OpenMCT, please tell us about it. In many cases, we find out about who's using our software by Googling it. And we found, like, the Planetary Society was using us for LightSail 2. Some really interesting work going on in Germany, which Andrew knows about. We found out, I believe, by Googling ourselves. We do periodically do that. So we'd love a mechanism to have a better sense of who's using us. And with that, I think I've used up my slot. I'm going to hand it over to Andrew. So I'll stop sharing. And Chase, I assume we'll have Q&A at the end.
Okay, so let me, I'm just trying to figure out the screen sharing as well. I'm not super familiar with, I'm not super familiar with Zoom because we're not allowed to use it in NASA. Just a moment. Sorry, I have to.
Andrew, are you seeing a bunch of question marks on the screens that you might be able to share in that interface?
Can you guys hear me okay?
Yes.
Hello?
Yes, we can hear
great.
you.
We can hear you, but we cannot see you or your screen.
Okay, my apologies. Having a few technical issues here. Let's see.
We can see your screen now.
Fantastic. Okay, great. And you can just see the presentation. You can see the title slide.
Yeah, I'm looking at a whole web browser, but the title slide is in there.
Okay, that's fine. That's perfect. Yeah, sorry about that. Alrighty. So I wanted to start out by sort of placing OpenMCT within a ground data system, just to give you a sense of sort of where it fits within a GDS and where the boundaries of OpenMCT are and what the interfaces are with sort of other components of the ground data system. So OpenMCT is a browser-based application. So it's basically just a bunch of JavaScript and HTML and CSS. It's designed to be sort of agnostic of kind of where it gets its data from and where it stores its data. The intent being that it can easily be kind of fitted into different kind of ground data systems, depending on what the sort of mission, what each mission is using. So it's intentionally kind of agnostic. It's not tied to any particular backend, and instead we have sort of an adapter layer that allows it to talk to different telemetry backends. Let's kind of go around this diagram. We've got OpenMCT running in some web browsers over here. These are our kind of mission users, our spacecraft operators, our scientists, etc. Down at the bottom right here, we've got a web server. So OpenMCT can be hosted by any web server because it is, as I say, just some static files. So you can use Apache, Nginx, Express.js, whatever you like. OpenMCT needs a telemetry source of some kind. So if you just download it and run it, we have some sine wave generators in there so that you have something to look at. But if you want to do anything useful with OpenMCT, you're going to want to connect it to a real source of telemetry, and that could be something like YAMS, which is an open source telemetry and commanding system. AIT, which is another open source telemetry and commanding system out of JPL. AMPCS, which is in the process of being open sourced. It's out of JPL as well. ITOS and kind of other systems. And typically, when you load something like a plot in OpenMCT, it's going to do two things. It's going to request a bunch of telemetry values in order to kind of backfill data for the period of time that you're looking at. So as you'll see in the demonstration that Charles is going to give, OpenMCT it's configured by the user to always be showing data for a particular kind of span of time. And so yeah, so on load, OpenMCT will request telemetry values in order to kind of backfill its displays, and then it'll also subscribe for new telemetry. And what that looks like from a technical perspective is historical telemetry is generally fetched via sort of like an HTTP GET request to a telemetry backend. So and which would typically respond in with some JSON data, but it needn't be JSON. As I say, we're pretty agnostic, and we have an adapter layer, and you could write a plugin that supported protocol buffers or whatever it was that your backend system is using. And then real-time telemetry streams are generally managed over WebSockets, but again, they don't have to be. We have at least one environment where we are sort of just polling via HTTP GET, or you could do kind of a chunked HTTP GET as well. It just depends on what your backend system supports. And again, OpenMCT doesn't really care because that's abstracted to an adapter layer. If you don't want to write code, you don't want to have to define your own adapter layer, that's also fine. If you're using, there are a number of existing plugins that have already been written that work with some of these, like YAMPs and AIT, and there's an AMPCS one that's coming as well in the near future. I'll talk a little bit more about that in a moment. And then down in the bottom left-hand corner here, OpenMCT needs somewhere to store its stuff, essentially. So what you'll see when Charles gives his demonstration is that the OpenMCT user interface is really flexible in that it allows users to kind of build display layouts and plots and tables and all these kinds of things using kind of a drag and drop interface. And out of the box, OpenMCT will just store those in local storage if you don't tell it to do anything else. But if you want to be able to easily share those displays with other people on your team, for example, then you'll want to configure some sort of shared persistence store. And out of the box, OpenMCT supports CouchDB and Elasticsearch for these purposes, but we also have an API that allows you to build plugins to work with another persistent store if you wanted to. So if you wanted to save your stuff in a SQL database, you could do that as well, so long as there was some sort of web service fronting it. Okay, moving on. Talking a little bit about the tech stack for those who are interested. It's mostly written in vanilla JavaScript with I've said ES6 plus because it's a mix of we basically use any language constructs that are supported across all of the major browsers. We use Vue.js for our UI components. Vue has replaced Angular.js, although we still have some legacy code in there because Angular has been retired. Angular 1 has been retired by Google. So we've switched most of our views over to Vue.js. There are some other libraries that we sort of use sparingly. We use D3 here and there, and we use Lodash a little bit. But we try to stick to vanilla JavaScript as much as we can. If you're building plugins for OpenMCT, you are free to use whatever libraries and tools you like. If you want to build your plugins with TypeScript, there's nothing stopping you from doing that. Our API does not impose any libraries or frameworks on you. If you prefer using React to Vue or Angular or whatever, that's entirely up to you, and OpenMCT will let you do that. We talked about integration a bit before. This is kind of a more complete list of what OpenMCT can be integrated with right now in terms of the plugins that are available. So there's a plugin that will get you up and running with YAMPs pretty easily. AIT, I mentioned, AMPCS, that's coming soon. CouchDB and Elasticsearch, I mentioned. An open source user has built a plugin to integrate OpenMCT with ROS, which is the robot operating system. And an open source developer also built a plugin to integrate OpenMCT with Kerbal Space Program, which is kind of cool. So what does building a mission control system with OpenMCT kind of look like? So I've kind of laid out a scenario here in which you have a ground data system, which if we look over on the right here, let's say you're using YAMPs as your telemetry source. You want to persist things to CouchDB. You have let's say you have a Kafka setup running, and there are some messages going over Kafka, and you want to show them in OpenMCT. And then let's say you also want to show a 3D representation of your spacecraft. So you've got some web services that are providing, ephemeris data backed by Spice or something like that. So let's go through quickly how you would kind of set up something like this. So for some of these, CouchDB and YAMPs, we have plugins for these available. So that's just a case of installing these existing plugins. So in this kind of center box here, I've got this section with existing plugins where it's just a matter of installing the plugins and providing some configuration. For example, the URL to your CouchDB backend. So that would use some of the existing capabilities of OpenMCT or freely available plugins. But for some of these other cases, so Kafka, we don't have Kafka integration right now, so that's something that would need to be built. But we have OpenMCT does expose an API for doing that. So if I wanted to build a plugin that allows me to show messages that are coming across the Kafka bus, then I could define a new telemetry provider, what we call telemetry providers. So this just basically, a telemetry provider knows how to talk to a particular telemetry source and then transform that data and expose it in a way that OpenMCT understands. And we have a tutorial that kind of walks you through how to do this for those that are kind of more interested in kind of going into more depth here than we have time for today. And let's also say that for my Kafka plugin, I want some sort of on-screen indicator that shows the user when I'm connected to Kafka. Then I could register a new indicator as well with the OpenMCT API. And then for my 3D spacecraft plugin, I can register a new view type with OpenMCT that loads maybe like the Unity web player, loads my 3D assets, and then it goes to these web services to get ephemeris data to show it at the right point in space and so on. So the point I'm trying to get at here is that the idea with OpenMCT, the idea with making it open source, with making it extensible through plugins, is that we kind of build on each other's work. So we built a CouchDB plugin. We've built a YAMPs plugin. Other folks have built and open sourced their own plugins for OpenMCT. So when you're customizing OpenMCT for a particular mission, you can go online, grab the plugins that already exist, and if they don't exist, then you can kind of customize it yourself by building your own plugins using our open source API. This is just kind of a slightly longer list of some of the ways that you can extend OpenMCT. So you can define new views and visualizations for your data, new telemetry adapters to integrate with different telemetry sources, object types and object providers. So Charles will talk a little bit more about what objects are when he gives his demo. You can define new actions. So these are kind of like verbs actions that are performed on objects, essentially. Toolbars are ways that you can interact with objects and interact with views and so on. So plugins can define new toolbar items. You can pop up messages to notify the user about things. You can define new indicators. So an indicator is just kind of an on-screen element that's always visible in sort of our status bar at the top of the screen, and can be used for showing things like connectivity with backend systems. And so on. I think I've used up all of my time. I want to leave a decent amount of time for the demo. But if you're interested in checking out OpenMCT, that's the URL. And if it hasn't already been shared with you folks, then I can make sure that happens after this. So I don't know whether we wanted to do questions now, or just should we sort of push on with the demo and then address them at the end?
It's up to you, but I suggest we do the demo first.
Yeah, let's do
the demo first, because that's probably going to preempt a bunch of questions anyway. Cool. All right. Thanks, everyone. Over to you, Charles.
All right, cool. Thanks, Andrew. Give me 1 second to start screen sharing here. And let's see. Okay. Share. Okay, can folks see my screen at this point? Okay, great, thanks. All right, cool. So what we're looking at right now is OpenMCT. It is as Andrew mentioned, it's a web-based application. So this is just it running locally on my machine here in the Chrome browser. We're compatible with all sort of major modern browsers, even including Microsoft Edge. And wanted to kind of take you through basically the overall kind of our model and approach, and talk about the layout and then the capabilities of OpenMCT. The main rationale for OpenMCT and its capabilities is to allow folks doing a space mission or any other kind of mission where a lot of say telemetry or information has to be monitored about a system, to allow the operators who are doing that to see all the data that they need to be able to see in the way that they need to see it, and to be able to compose, share, and save displays ahead of time. So that has been a primary driver around the design and the capabilities of what we do. So one thing I'll show you, for instance, is how I have composed this particular display layout here, for example. And by that way, I'll show you a number of the different abilities that OpenMCT has. So, so the main interface is basically broken up into sort of 3 major areas. On the left-hand side here, we have this tree element, and that's giving the operator, the user, access to everything that they have available to them. And so when OpenMCT gets configured for a particular mission, for example, there might be a thing called a mission dictionary, which is the sort of canonical set of telemetry endpoints and data, basically just data, that discrete data elements that they might have available to them. That would be accessible in this sort of expandable tree here on the right-hand side. Because I'm running locally here, I don't have one of these, so I can't really illustrate that, unfortunately. But the idea there again is that that's a non-editable thing that has been blessed and has been configured as part of a deployment. The key there is that it gives users the ability to look directly into data that they have available to them very quickly and easily, and then to also use those elements inside displays that they compose themselves. More on that soon. The tree also holds all the elements that I myself might create or other users of the system would create. OpenMCT is pretty flexible in how it can be configured. For instance, one of the configurations that we do for a lot of users at JPL allows them to use a security layer that sits in front of OpenMCT that recognizes who a user is logging in. Once a user is logged in, then they have a folder, for instance, where they can create and edit things themselves, but they're not allowed to do that in other users' folders, although they can see what's in other users' folders, so they can reuse elements from those places as well. Again, OpenMCT is pretty flexible about this. You know, in other cases, we just kind of, it can be the Wild West where basically everybody can see everything that everyone else has done and even edit things that everyone else has done. And we kind of leave it up to, you know, more sort of personal interactions and rules within the organization to determine, you know, how that works out. Anyway, you can see here, there's a variety of sort of different types of items. All the different kinds of things that you can create are available in this create menu right here. So I can basically create a new thing at any given time. And I'll get to that here very shortly. Over here on the right, in the middle rather, sorry, in the middle is what we call the main view area. And whatever I've navigated to here in the tree, and you can see that it's highlighted here, is displayed in this main view area. This actually happens to be a display layout, which is basically just a sort of a 2D canvas area that allows you to include other objects that are in OpenMCT and position them and size them and determine other properties about how they are displayed. So if I click on, say, something else, for instance, I'm going to go to the main view for that object. So this is a notebook element. This allows people to create basically log entries and to also take snapshots of different views and include those in an entry and to annotate and save comments and information about them. And I'll actually show that in a little more detail in a little bit. So just to kind of take a tour of some of the other elements. Right here, I have basically a telemetry endpoint that is being displayed as a plot. But the thing about OpenMCT is that we want to allow you to explore data in different ways. Any type of sort of time serialized data could be represented as a plot, or you could look at it as a table, for example. And I can easily switch to that table view by simply toggling this view here. It's the very same data, it's just being displayed in a different way. Here we have an imagery viewer. So if you have image telemetry, you can configure OpenMCT to display images in this fashion. And what I have here right now is whatever my most current image is. And all these images, by the way, are all sort of from Apollo, hopefully pretty obviously. And they're just part of this example imagery element, which is something that ships by default with OpenMCT. But I can click back into any past image, for example, and I can then freeze my display. And I get a warning in that regard because I'm in real-time mode right now, and I'll talk more about that in a minute. But the idea is that if the user is expecting to see real-time data, that if they are exploring past data and they're not going to see the latest data, we want to warn them and tell them that that is the case. And in order to get back to seeing the latest, there's a variety of ways they can do that, but principally they can click this play button and sort of get back to looking at whatever the latest data is. And let me talk about time here for just a second while I'm talking about that. This element down here on the bottom is called the time conductor. And what that does is that controls the time context for the application at large. So many views and components in OpenMCT are time aware. Some elements and components, for instance, only really operate in real time. They make no sense sort of to view with historic data. But in the case here, for instance, this imagery element is definitely time aware. And so what the time conductor does is it basically sets the overall time context for whatever data queries are that the user's looking at. So in this case here, this is a real-time mode, so it's treating time as a sort of moving window of time. And what that means is that I can either increase the width or narrow the size of that window. So in this case here, I'm looking 30 seconds into the future, and I'm looking 5 minutes into the past. And I'm only going to see an image stack here in history that fits within those parameters. So if I actually come in here and I change this to say 15, I'm actually going to end up getting a lot more thumbnails to the left. And let me actually go to this element here to illustrate that a little bit better. So here I am in a 15-minute time frame, but let's say I change that to a 2-minute time frame. Then what's going to happen is I'm only seeing 2 minutes worth of data, and everything is going to apparently move faster. Why this really matters is that it allows us to, say, control a series of different interfaces or different component views all at the same time. So here I am in the display layout, which includes a plot, a table, this example imagery element here. And if I change the time conductor context from 2 minutes to say 22 minutes, then everything that's time conductor aware is going to update. So it allows users to sort of synchronize their time views and explore those time views in a way that makes it easier to kind of control the view as a whole. OpenMCT also allows us to use what we call a fixed time mode. And in this is treating time as a discrete date time, a discrete span of time with a discrete start and end. Having switched from real time to fixed time, it's automatically going to set my fixed time to basically what the current window of time was when I was previously in real time. But I can change that here. For instance, I can change this from say 420:18 to 420:14, and then that's actually going to increase the amount of time I've got. It's going to do a query to the historical server, and it's going to backfill any historic data into my view. Why this is important is that many NASA tools in the past either did historic data or they did real-time data, but they didn't do both at the same time. And one of the big things we went after in the design of OpenMCT was to bring those together. So if I'm looking at a real-time segment here of 30 minutes and I change that to an hour and 30 minutes, what's going to happen is it's going to keep giving me real-time data, but it's going to do a historic query and take all that previous hour that I didn't have in view. It's going to pre-pen that into my data and seamlessly display it together with the incoming real-time data. So that's actually fairly revolutionary within NASA at this point. So let's see. Let me pay attention to time. All right, I'm going to show a little bit of building. So I've talked a little bit about some of the various components and views that OpenMCT supports. So we've seen plot view and table views. We can also create plot views. And so by doing that, that will allow me to actually combine one or more different telemetry elements together into the same view. So here I'm just going to create an overlay plot. And it's just as simple as going to the create menu, choose overlay plot, and I get into this dialog. I have to name it, say where it's going to be saved, hit OK. And now I've got this sort of blank canvas in edit mode. And I can go up and I can drag in any telemetry element I want, like this, drag and drop it, and it will automatically be added. I can configure a lot of the properties of the things that have been added. So for instance, if I want to change this plot series here, and I want it, instead of using a linear interpolation, I want it to use step after, I can make that change. If I want it to be a different color, I can do that. And then it's just as simple as I can just save that and I'm done. Same idea with a table view. I can create a table view and then drag in any telemetry element I want. In this case here, I'll edit an existing one. This one is including this telemetry endpoint down here, but I can also easily drag in another telemetry point, and that is going to, again, seamlessly add into this current view. And I'll go ahead and save that. So display layouts. Display layout basically allows the user to create screens and displays that really suit their needs and purposes and what they're doing for their job. So I'll just show you really quick how I might say rebuild this particular display. So I'm just going to come up here, hit create a new display layout, and say where to save it. Hit OK, and that's going to get me into a blank display layout. Now, one cool thing is that because of the tree, the availability of the tree here and the ability to look inside any element that I or anybody else has created, is that now I can actually go into my older display layout that I showed you the first time around, and I can actually see all the elements inside it. And if I want, I can literally just raid that and drag those in directly from there. And even if somebody else had created another display layout, I can actually, if I want, I can bring that whole display layout into my display layout. I don't want to necessarily do that right now because I think that might be slightly confusing. But the point being is that the object-oriented nature of OpenMCT, because if I change any one of these objects, if I change anything about that overlay plot that I created, or if I change anything about this layout, everywhere else that element's used is going to be updated. So it allows you to create reusable components that people can then bring into their own displays and always be assured they're going to have the most up-to-date version. Obviously, change control becomes a consideration when you get into things like that. And we're going to be actually building in, we think, some sort of ability to lock things down. And when a particular display has sort of been canonically blessed, but we don't have that yet. So anyway, let me kind of rebuild this really quickly. So here's this image element that I had. I can drag in a table. Then I can size and position that. I can bring in these condition widgets, which basically one of the things that we can do in OpenMCT is we can create a condition set that actually looks at the value of telemetry in time and allows the user to define conditions. So for instance, if a temperature sensor on board a spacecraft that might be measuring the temperature of a chip or something on a board exceeds a certain value, I can have that, I can say what that value should be and have a condition rule that would then be matched. And I can use that condition rule here to say that when that condition is matched, like in this case here, like I have a default, which is green. But if a value goes over a certain level, I can make it be orange, or if it goes over another value, I can make it be red. So this allows people to create warning buttons and allows them, I can even make a button type of thing like this, or I can even apply that styling to other views like tables or plots even. So if I wanted to make things start to be more dynamic when things are going wrong, we have a way you can do that quite easily. Let's see. So I'll bring this button in right like this, and do that. And also too, at this point we're about 10 of. So I mean, at this point, I think I've kind of run through most of the stuff I wanted to show, and I wanted to definitely allow time for questions. So if I can kind of sort of keep just constructing this here, but people can ask questions as well if they like.